Now I'm going to demonstrate another type of aggregation called count. Again, we're still in real estate data set. I'm going to bring sale date in 2 columns, and I'm going to take my transaction ID and bring it into rows. We've got a little window that popped up, and it's asking me whether I want to bring in all 77,537 members into the view. I will just say add all members, and this is what happens. Let's discuss first why it happened. If we go to the original data source, we can see that our transaction ID is basically a unique ID for every sales transaction. It's very important, besides understanding each variable in your data set, understand what each row means. In this case, in our real estate data set, each row represents one real estate sales transaction, and it's got a unique ID. So each row has a unique ID. It's got a date. This transaction number 1644233 took place on June 30th, 2017. The sale took place in Baldwin County in an unincorporated area in this zip code. This was the value of the home. This was the price that was paid for the home. There was 0 mortgage amount on that home, and it was an existing home. It was a resale. It was not a new construction. So again, each row represents a unique sales transaction that's represented by this unique transaction ID. And so now transaction ID is it's a discrete field. It's a dimension, and it's a discrete field. It makes no sense, although these are numbers, it makes no sense to add them up. There's no reason why we should want to add up unique identifiers together to make it a certain number, because that's not going to tell us anything. But what we can do is take advantage of this count aggregation. So we select measure, and instead of summing up transaction IDs or averaging them, we can count them. And now our pill has changed to green. It became continuous, and what happened was it counted all unique IDs. It counted all unique transactions that took place each year in those 2 counties. Okay, we're gonna show the view in a continuous monthly view. So our scale goes from 0 to 1700. So between January of 2014 until December 2018, we've got anywhere from 0 to 1700 transactions taking place on a monthly basis in both counties. If we wanted to break the view by county, we can do that. We can see that a lot more homes sold on some occasions in Mobile County. Okay, let's see what happens if we bring county pill to rows. We still break down our view by county, but now we've got county in row rather than in column. Okay, now let's say that we would like to label these charts. What we can do is we take transaction ID and we drag it into label. But oops, something happened. What happened was we're running into the same problem that we had here in rows earlier. Our transaction ID should be a continuous or green field with aggregation count, but that's not the case for labeling. So we have to make sure that we are labeling this the same way we're displaying it in our view. So we're going to take our pill, our transaction ID pill under label. We're going to tell Tableau to measure it as a count. And now we've got what we were looking for. We're showing in our view count of transaction IDs, and we're labeling count of transaction IDs. It's very important, and when we are labeling our charts, that we stay consistent with telling Tableau doing the same thing in rows or columns and in labeling. and then all other functions in this marks shelf that we'll discuss later. I'm going to demonstrate one more aggregation, and that's going to be count distinct. And for that, we will use our coffee shop dataset. We'll pull date in 2 columns. We only have 1 year of data in our dataset, so we're going to go down as granular as a day, continuous day in this case, because we only have 2 months worth of data. And I'm going to pull net sales into our view. Our scale goes from 0 to 3,400. Our data spans from April 1st of 2019 until May 31st of 2019. This is sum of net sales, and so we've got 60 marks because there are 60 data points between April 1 and May 31st of 2019, and each data point on this chart represents sum of all net sales for each day during those 2 months at this coffee shop. Now let's say that instead of trying to find out what were my sales each day, I want to know how many tickets I issued. So I've got a field here, and it's a discrete field called ticket, and I'm going to pull it in my rows. Again, I'm being told by Tableau there are over 22,000 members in this variable, and they're asking me if I want to bring all of them into the view. I'll say yes, but this is the view I get. That's not what we were hoping to do. Let's look at why we're getting this view. Let's now look at our data source. We see that we've got a column named ticket, and again we've got to ask ourselves, what does each row in our data set mean? If we go column by column looking at the first row, we've got a ticket number 2248961. So a ticket was issued on April 2nd, 2019 at 19 hours and 52 minutes. That's 7:52 p.m. And these are just alternate date and time fields. Item ID that was sold was this. It was an iced Alpine Mocha, 20 ounces. Category was espresso based, and it was sold in quantity 1, and it costed this much. Okay. Now let's look. Another row is a different ticket number with an item sold as iced mocha, 20 ounces. But the next 2, 3, 4, 5, next 1, 2, 3, 4 rows have the same ticket number, but different items sold. Actually, 3 were same. There were 3 Ghirardelli chocolate desserts, some peanut butter scream frozen drink, and then iced mocha, but they all fall under 1 ticket. That means that one person came in, bought these 5 things, and they all showed up on 1 ticket, but this ticket is spread across 5 rows because 5 items were purchased. So now we're finding an answer to our question, what does each row of data in our data set mean? Well, each row means a single item sold to a particular person on a particular ticket at a particular time and date. Okay? So while our ticket number is unique to each ticket, it's not unique to each row. In practical application, we can technically think of each ticket as an order. A customer walks in, orders 1 or orders multiple items, and they're most likely end up on 1 ticket. So 1 ticket would be considered an order. So if we want to know how many tickets were issued each day, Now what we have to do is to ask Tableau to measure count distinct. Now our pill changed to green, continuous. The abbreviation for count distinct is CNTD, and our scale changed from 0 to 500, and we've got 60 marks in our view, and distinct count of tickets for April 1 of 2019 is 393. Distinct count of tickets for April 2nd is 389. That means each data point tells us how many tickets were issued that particular day in this coffee shop. That's the difference between count and count distinct. We need to be careful about what we're counting, because if we just want to count rows, then we can use the count aggregation. But if we want to know the distinct count of items in our column, then we need to use this function. Again, if we want to label this chart properly, we're going to pull ticket into label, and we're going to tell Tableau to count distinct. And we're back to having a continuous chart giving us distinct count of tickets issued each day between April 1st until May 31st of 2019 in this coffee shop. And we can tell that most tickets were issued on April 19th, and the least tickets were issued somewhere at the end of May. These were the 4 most frequently used aggregation functions in Tableau. There are others that you can explore and use as you wish, but I hope this was informative, and more videos are coming. Stay tuned, and thank you for watching.